division. It's really fun. You will love it. All right, so solve the polynomial. We have x to the third minus 6x squared plus 10x minus 8. First thing you do, check to see if you can pull a greatest common factor out. Well, x to the third, x squared, x, 8 doesn't have an x on it. Okay, lost out there. See if I can pull a number out. Nope, and there's no number in front of that x to the third. So basically, I'm stuck. I'm stuck where I am. I have x to the third minus 6x squared plus 10x minus 8. I cannot factor anything out of it as far as a GCF is concerned. So now we need to see if we can find a solution. And it turns out that a solution, so think back to when we factored the quadratic, right? You look at the numbers on the ends, you multiply those to get the coefficient on the end. So in this case, I can look at that negative 8, and the number that goes here and the number that goes right here must multiply to be 8. And if you need to, go back, review that quadratic, factoring quadratics, and you will better understand this. Or this step I just said. But those two numbers multiplied together better give me 8. So what I want to do is look at all of the factors of negative 8. So 1, 2, and 4, and 8. But not only those, but also the negative values. So all of the factors of negative 8 is 1, 2, 4, and 8. Not just positive values, but also the negative values as well. Now, these are all possible solutions to the given polynomial. So what that means is that they're possible solutions, meaning I could, and hopefully somewhere in here, plug these values in for x into x to the third minus 6x squared plus 10x minus 8 and get a 0 out. For example, if I plugged in positive 8, simplified and I got 0, 8 would be a solution. So what we need to do is see which one of these is a possible solution. So I'm going to pick number 1. And I'm going to plug 1 into here. Now what I'm doing is testing to see which one of these numbers is a possible solution. So I'm going to go ahead and I plugged in number 1. So I'm plugging in this guy right here and I'm seeing if it's a solution. So 1 to the third power is 1. 1 squared is 1 times negative 6, so minus 6. And then 1 times 10 is plus 10. And then, oh yeah, negative 8 on the end. There we go. All right, so let's combine these. 1 minus 6 is negative 5. And then I still have plus, well, I can do 10 minus 8, which is 2, positive 2. And then negative 5 plus 2 is negative 3. Now, what this tells me, I got negative 3 when I simplified it. That tells me that 1, the number 1, is not a solution. That also tells me, so 1 is not a solution, so x cannot equal 1 because 1's not a solution. But that also tells me that x minus 1 is not a factor, because where do I get my solutions? I get my solutions from the factors. I get the factors from the polynomial. So looking at this, in this case, I tested to see if 1 was a solution. It wasn't. Therefore, x minus 1 is not a factor. So what we have to do basically is test each and every one of these. We need to test number 1, 2, 4, 8, negative 1, negative 2, negative 4, negative 8, and do the same process, plug them in, until we find one that gets us a 0 when we simplify. So instead of negative 3, we want 0 there. And when we do get 0 with one of these, that gives us one of the solutions. Not all of them, it just gives us one. But not only does it give us a solution, it gives us the factor as well. Okay, so I want you to go ahead, pause the video, and test each one of these to see which one is a solution. Go. All right, so hopefully you have now found the solution, and in this case, positive 4 is a solution. Now, what that tells me is that x equals 4 is a solution. It is a solution. But that also tells me that the factor, one of the factors, not the only factor, but one of the factors is x minus 4. The coolest thing in the world. And if you plug in 4, you get 0. And this tells me that x minus 4 is a factor. That means I can pull out, or I can factor out x minus 4. Coolest thing. So I have right here, x minus 4 is a factor. And I want to know, x minus 4 times what will give me x to the third minus 6x squared plus 10x minus 8. Okay. So I'm going to go ahead and, oops, sorry, I accidentally clicked back. My bad. But I'm going to go ahead and actually pull that x minus 4 out. And what you get to do is use long division. Now, this is a long process, of course, which is why they call it long division. But we're going to go ahead and divide this polynomial by x minus 4. And what we get on top here will be this question mark. So because think of regular long division that you guys have been doing forever, right? On top, it's this times x minus 4 equals what's there. So we're going to go ahead and do this. Now, if you need a refresher, I'm going to go ahead and go through this, but if you need a refresher on long division, you can go ahead and click on the video link in the upper right-hand corner, and that'll kind of walk you through a more kind of zoomed in approach of long division, or explain it in more detail is what I should say. But anyway, so let's go ahead and do this. So I've got x squared times x is x to the third, and then x squared times minus 4x is minus 4x squared. And then I'm going to go ahead and subtract these because long division, it's this, what's on top times the side, put it under here, subtract it. So then I have minus 2x squared. Be careful when dividing and subtracting. I'm not dividing, sorry, multiplying and subtracting. Wow, I keep wanting to say dividing. Obviously, this whole thing's division, but when you subtract, it's minus x to the third minus a negative 4x to the third, which makes it plus 4x squared. Okay, be careful. I'm going to go ahead and extend this and bring down my 10x. And then let's go ahead and be negative 2 times negative 2x. Oops, that x does not look like an x. I'm just going to extend that a little bit. Well, that's a little better. Negative 2x times x is negative 2x squared. And then negative 2x gives me positive 8x. And then I'm going to go ahead and subtract these. Don't forget about this negative 8 up here. Subtract them. I'm left with, goes away, and 2x. We got a little sloppy on that one. Actually, kind of, it's all sloppy. But anyways, bring down, I'm going to extend this and bring down your negative 8. And then I'm going to go ahead and keep on going. So I've got a positive 2, gives me 2x. And then 2 times negative 4 gives me negative 8. Nice. And then I subtract them. That gives me 0. Now, that is huge right there. I just got 0 when I divided and for my remainder. And I should get 0 because I already said x minus 4 is a factor because 4 was a solution. If 4 is a solution, therefore x minus 4 better be a factor. Now, what I just did here is basically I took that polynomial x to the third the third degree polynomial, and I divided out x minus 4. So this tells me I just figured out what this is right here, that question mark. That is x squared minus 2x plus 2, because x squared minus 2x plus 2 times x minus 4 gives me this third degree polynomial. And of course, you better get 0 down here. If you don't get 0, check all of your work when dividing, all of your work. If you didn't get 0, you probably did a simple addition or subtraction error. But if you're doing a problem that's not this, and you're working through and you don't get 0, you messed up on one or two things. You didn't divide correctly, meaning the whole process that I just went through, or you messed up in saying that the number that you thought was a solution, and it's not. Okay? So in this case, if I didn't get 0, I would look through my work, and then if I think my work's correct, I would test again, is 4 an actual solution? So I'd plug 4 back into the third degree polynomial and see if I get 0 out. So anyways, those are two spots you could have gone wrong if you don't get 0 when you divide. But in this case, I did. So now I have it. I have x minus 4 times x squared minus 2x plus 2. Those are my factors. Nice.